Alrighty, Common Core Algebra 2, Unit 1, Lesson 1, the homework. So, number 1 asks us to multiply these two polynomials together and combine like terms. So I'm going to do this one using the distributive property. You could do it with the tabular method. So I'm going to pick up x minus 4 and distribute it to the x, and then distribute it to the 5. So we get x times x minus 4, and then plus 5 times x minus 4. Now we use the distributive property two more times, and we get x squared minus 4x plus 5x minus 20. Combining our like terms here, we get x squared plus x minus 20. So the answer for number 1 is x squared plus x minus 20. Alrighty, multiply x squared minus 4x plus 4 times x plus 3. I'll do this using the table, using the tabular method. So I'm going to make a table. I'm going to put x squared minus 4x plus 4 and x plus 3. We get x squared times x is x cubed minus 4x squared plus 4x, multiplying each of those terms there. Now I have x squared times 3, which is 3x squared, minus 4x times 3 is minus 12x, 4 times 3 is 12. Now again, notice that our like terms are on our diagonals. So I get x cubed. These are my like terms. These are both my x squared terms. We add them together. Minus 4x squared plus 3x is minus x squared. 4x minus 12x is minus 8x plus 12. So that product is x cubed minus x squared minus 8x plus 12. Alrighty, number 3, 3 by 3. So my table's going to have 3 rows and 3 columns. X squared minus 3x plus 9, x squared plus 3x plus 9. So we're going to go through and say x squared times x squared is x to the 4th, minus 3x times x squared is minus 3x cubed, 9 times x squared is 9x squared. X squared times 3x is 3, and then x squared times x is x cubed. Minus 3x times 3x gives me negative 9x squared. And 9 times 3x is 27x. X squared times 9 is 9x squared. Minus 3x times 9 is minus 27x. 9 times 9 is 81. Again, notice how all of our like terms are on the same diagonal. Those are my x cubes, those are my x squareds, those are my plain old x's. We add all these terms together. So the product equals x to the 4th minus 3x cubed plus 3x cubed is 0, so we don't even write that term. 9x squared minus 9x squared plus 9x squared. Those two terms add to 0, so I'm left with plus 9x squared. 27x minus 27x is 0, plus 81. So the product is x to the 4th plus 9x squared plus 81. Find this product. I'll do this one using the distributive property because they're only binomials. So I'm going to take the whole term 2r plus 1, multiply that into 2r squared, and multiply it into 1. So 2r squared times 2r plus 1, and then plus 1 times 2r plus 1. We treat the 2r plus 1 as one big object. And now we apply the distributive property two more times. 2r squared times 2r is 4r cubed, plus 2r squared plus 2r plus 1. There's no like terms to combine, and that's written in standard form. Remember that standard form, the exponents decrease in power. Number 5, this is a big one here, but we don't need to freak out because we're just going to use a table. So this has 4 terms, that has 3 terms. So 3m cubed plus 2m squared minus 2m minus 5, m squared minus 5m minus 6. 4 by 3. 3m cubed times m squared is 3m to the 5th, because I'm multiplying 5 m's together there. This term is 2m to the 4th. M squared minus 2m is minus 2m cubed, and then minus 5m squared. The next row, we get negative 15m to the 4th minus 10m cubed plus 10m squared plus 25m. Remember, we multiply to get these boxes. Minus 18m cubed minus 12m squared, 12m, 30. So now we have our like terms along our diagonal. So we get out 3m to the 5th, 2m to the 4th minus 15m to the 4th is minus 13m to the 4th, minus 2m cubed minus 10m cubed minus 18m cubed is minus 30m cubed, minus 5m squared plus 10m squared minus 12m squared. So I have minus 17m squared plus 10m squared is minus 7m squared from that diagonal. I have 37m plus 30. So our final answer is 3m to the 5th minus 13m to the 4th minus 30m cubed minus 7m squared plus 37m plus 30. If you can do this one, you can basically do any of the questions. And finally, number 6. If I'm multiplying 3 polynomials together at once, let's do it 2 at a time. So t minus 1 times t plus 1. That's t minus 1 times t, and then 1 times t minus 1. We distribute that t minus 1 in. So that product is t squared minus t plus t minus 1. That's t squared minus 1. So now I want to find the product of t squared minus 1 times t squared plus 1. And I'll do this using the table. You can do it either the distributive property or using a table. So this is only a 2 by 2, t squared minus 1, t squared plus 1. We get 2 to the 4th minus t squared plus t squared minus 1. Combine my like terms, we end up with 2 to the 4th minus 1. Now, I know we haven't talked about factoring difference of perfect squares, but I hope you recognize that t minus 1 times t plus 1 is the difference of perfect squares. And then over here, t squared minus 1 times t squared plus 1 is also the difference of perfect squares. So we're going to get to that, but that's just something to mention. So on to the Algebra 1 review. Factor these polynomials completely. The first polynomial is t squared minus 25. Again, this is the difference of perfect squared. T squared is a perfect squared, 25 is a perfect squared. So hopefully you remember from Algebra 1, that factors as t plus 5 times t minus 5. 2y squared plus 6y plus 8. The first thing we do whenever we factor is we look, is there a GCF? I know there's a GCF between 2, 6, and 8. That's a 2. Not all of the terms have a y, so I can only factor out a 2. And I'm left with y squared plus 3y plus 4. It's said to factor completely. So can I factor this trinomial? What numbers multiply to 4 that add to 3? There aren't any, so that's factored completely. And finally, this last trinomial over here, 2n squared plus 7n plus 3. We're going to go over factoring trinomials with leading coefficients. This was just to have you think about it. Probably you learned how to do it using the guess and check method. We're going to develop another way, but the solution is 2n plus 1 and n plus 3. So if this one was a little tricky for you, don't worry about it. We're going to come up with a quick and easy procedure on how to do that. Probably lesson 7. So factoring, we definitely need to know how to do because we don't have that much time to review it. Alrighty, number 8 says let f of x equal x squared plus x minus 30 Algebraically determine all values of x such that f of x is 0. So I want to know, when does this function output a 0? So I know that's f of x. I want to know when it equals 0, so I'm going to do x squared plus x minus 30 equals 0. In Algebra 1, you came up with 3 ways to solve a quadratic equation. One was factoring. We can factor. 2, we can complete the square. Or 3, we can use the quad formula, the quadratic formula. Quad formula. Factoring is probably the most direct way to do this one. What multiplies to negative 30 that adds to 1? Well, that's negative 6 and positive 5. So I know x squared plus x minus 30 is equivalent to x minus 6 times x plus 5. If I multiply two things together and get 0, either that thing is 0 or that thing is 0. So our solutions are x equals 6 and x equals negative 5. So those are the values of x such that f of x equals 0. Remember that these are called the roots, or the zeros, or the x-intercepts. Number 9, a function in the table to the right. A function is shown in the table to the right. If added to the table, which ordered pair would result in a relation that is no longer a function? Explain your answer. So the key thing about a function is a relation where every input has only one output. So negative 4 is the input, 2 is the output. Negative 1 is the input, negative 4 is the output. So which ordered pair would I have to add to this table so that it would not be a function? Well, if I add negative 4, 1 to that table, if I input a negative 4, what do I get out? Do I get out a 2 or do I get out a 1? We don't know. So negative 4, 1 would be the ordered pair that would make this not a function. If I added 1, negative 4, that's okay, because 1 goes to negative 4 and 1 doesn't go to anything else. Your y values can repeat. You can have two y values of negative 4. You can't have your x values repeat. Also, I'll say this now, explain your answer. Explain your answer means that you are writing a sentence out. And finally, number 10, let f of x equal x squared minus 2x. Evaluate this expression. Do you remember what this represents? So f of 3. Remember, this is function notation, not multiplication. This means plug a 3 in for x. So we're going to do 3 squared minus 2 times 3. 3 squared minus 2 times 3 is 9 minus 6, so f of 3 is 3. We also need to figure out what's f of 1. F of 1 is 1 squared minus 2 times 1, which is 1 minus 2, which is negative 1. So when x is 3, the y value is 3. When x is 1, the y value is negative 1. So 3 minus negative 1 over 3 minus 1 is 4 over 2, which is 2. What does this represent? This expression is the average rate of change formula. Average rate of change. It's finding the slope between the 2 points on that parabola. So there's the parabola. Here's when x equals 3. Here's when x equals 1. This is not to scale at all. And the slope of the line connecting those 2 points is 2. So the average rate of change is the change in y over the change in x.